Let's get our hands dirty. Alright, let's talk about something that sounds complicated but is actually pretty simple when you get right down to it. VTOL, it stands for Vertical Takeoff and Landing. Now, I've seen a lot of things in my day, from cleaning out septic tanks to wrangling alligators, and most of them involve getting from point A to point B in a straightforward way. A car needs a road, a train needs a track, and for a long time an airplane needed a runway, a big, long, expensive strip of pavement. VTOL throws that whole idea right out the window. It's the simple, dirty, and brilliant concept of a fixed-wing aircraft, a plane that can go straight up and come straight down. Imagine a helicopter. It goes up, it comes down, it hovers. No runway needed. Now, imagine a jet fighter. It screams down a mile of concrete, claws its way into the sky, flies at the speed of sound. They're two different tools for two different jobs. VTOL is like someone looked at both and said, hey, I want one of those. It's the ambition to combine the best of both worlds. The ability to launch from a tiny clearing in a jungle, the deck of a small ship, or even a damaged airfield, and then tear across the sky like a conventional jet. It's about freedom, the freedom from the tyranny of the runway. This isn't just some fancy parlor trick for air shows either. This is about getting a job done, a dirty job, in places where the normal rules don't apply. Think about it. Warfare isn't always convenient. It doesn't always happen next to a perfectly maintained international airport. More often than not, the work needs to be done in some of the worst places imaginable, places with no infrastructure, no support, and no easy way in or out. So how does it work? How do you convince a machine that's designed to slice through the air horizontally to suddenly push off the ground like it's doing a push-up? Well, it's not magic, but it's a heck of an engineering puzzle. The secret is all about redirecting thrust. Thrust is the force that pushes an airplane forward. In a normal jet, that force comes out the back. Simple enough. But with a VTOL aircraft, the engineers had to get clever. They had to figure out a way to point that powerful jet blast straight down at the ground. It's like trying to stand on top of a fire hose that's going full blast. There are a few ways to pull this off, and different aircraft have their own unique and sometimes dirty methods. One of the most famous ways involves using rotating nozzles. Imagine the exhausts on a jet engine, but instead of being fixed in place, they can swivel. To take off, the pilot points these nozzles downward. The engine roars to life and a massive column of superheated gas blasts the ground, lifting the several-ton aircraft straight into the air. Once it's high enough, the pilot slowly rotates the nozzles backward, and the vertical lift smoothly becomes forward thrust. The plane is now flying like a regular jet. It's a beautiful, violent, and incredibly precise dance of mechanics and physics. Another method, which you see on some of the newer, more high-tech birds, is even more complex. It involves a dedicated lift fan. Think of a massive, powerful fan embedded right into the body of the aircraft, usually behind the cockpit. When it's time to go vertical, doors on the top of the plane open up, and this fan spins to life, sucking in a huge amount of air and blasting it downward. At the same time, the main engine in the back uses a swiveling nozzle to direct its own thrust down. It's a coordinated effort, a symphony of moving parts all working together to defy gravity in the most direct way possible. It sounds complicated, and believe me, it is. I've seen the guts of some complex machines in my time. Plumbing, wiring, hydraulics that make VTOL possible are on another level. It requires incredibly sophisticated computer controls to balance the thrust and keep the aircraft stable. One tiny miscalculation, and the whole thing could tip over. It's a testament to the engineers who figured out how to tame that raw power. It's a dirty, loud, and incredibly hot job, but the result is an aircraft that can do the impossible. It's pure, unadulterated power, pointed in a new direction. If you want to talk about VTOL, you have to start with the granddaddy of them all, the Harrier. This thing is a legend. It's not the newest, it's not the fastest, and it's certainly not the prettiest aircraft out there. But it was the first one to really get the job done on a large scale. The Harrier is a workhorse. It looks like it was designed by someone who cared more about function than form, and I respect that. It's a tool built for a very specific and very dirty job. First flown in the 1960s, it proved to the world that a jet fighter didn't need a runway to get into the fight. The Harrier's magic comes from its single Rolls-Royce Pegasus engine. This engine is a masterpiece of gritty engineering. It has 4 rotating exhaust nozzles, 2 on each side of the fuselage. When the pilot wants to go vertical, they pivot these nozzles to point straight down. The result is a deafening roar, and over 20,000 pounds of thrust blasting the ground, lifting the jet into the air like it's being hoisted by an invisible crane. The pilot can even vector the thrust slightly to move forward, backward, or sideways while hovering. It's a delicate balancing act that requires a ton of skill. This capability was revolutionary. Suddenly you could operate high-performance jets from small aircraft carriers or hide them in clearings in the woods. The Harrier saw real action, most famously during the Falklands War in 1982, taking off from rain-slicked decks, flying missions, and landing vertically in terrible weather. They proved that VTOL wasn't just a gimmick, it was a serious military advantage. Now let's talk about a machine that looks like it flew right out of a science fiction movie, the V-22 Osprey. This thing is a true hybrid, and it's one of the most unique aircraft you'll ever see. It's not really a plane, it's not really a helicopter, it's something in between, and its job is to do things that neither one could do alone. The Osprey is a tiltrotor aircraft, that's the key word. It has 2 massive propellers, rotors, mounted on the tips of its wings. And here's the trick, the engines and rotors can tilt. They can point straight up like a helicopter, or tilt forward to fly like a conventional turboprop airplane. When it's time to take off, the Osprey's rotors are pointed skyward. They spin up, creating lift just like a helicopter. The aircraft lifts vertically off the ground. It can hover, it can maneuver, it can land in a space not much bigger than itself, perfect for dropping off troops, or supplies in tight spots. But once it's in the air, the real magic happens. The pilot begins to tilt the rotors forward. As they tilt, the aircraft picks up speed. The wings start generating lift. Within about 15 seconds, the rotors face completely forward, acting like giant propellers. Now the Osprey flies with the speed and range of a fixed-wing airplane. This dual personality is what makes the Osprey such a valuable tool. A helicopter gets into tight spots, but it's slow. A conventional transport plane is fast and has long range, but it needs a huge runway. The Osprey gives you the best of both worlds. It can take off from a ship, fly hundreds of miles at over 300 miles per hour, twice as fast as the helicopters it replaced, then land vertically in a dusty village or on a remote mountainside to deliver Marines or rescue a downed pilot. It closes the gap between the front line and the rear support areas like nothing else. Of course, getting this revolutionary technology to work wasn't easy. The Osprey had a long and very troubled development. It's an incredibly complex machine, and there were tragic accidents during its testing phase. People wondered, was the concept too ambitious? Too dangerous? But engineers and test pilots kept at it, working through problems, refining software, and making it safer and more reliable. Today, the V-22 Osprey is a critical part of how the U.S. Marine Corps operates, and how the Air Force operates. It proves difficult jobs sometimes require the most innovative and sometimes controversial tools. So, if the Harrier is the old grizzled veteran, then the F-35B Lightning II is definitely the new high-tech prodigy. This aircraft, honestly, is a completely different beast. It's a stealth fighter, and it's packed with sensors and computer power. And on top of all that, it can take off and land vertically. The B in F-35B stands for short takeoff and vertical landing. STOVL, which is a close cousin to VTOL. It can take off vertically if it's not too heavy, but it usually does a short, rolling takeoff to save fuel and carry more weapons, then comes back to land straight down. The way the F-35B achieves this is just a marvel of modern engineering, and it's a lot more complicated than the Harrier's simple nozzles. It uses a system that combines a swiveling rear-engine nozzle with something called a lift fan. This lift fan, built by Rolls-Royce, is a massive 2-stage contra-rotating fan that sits vertically in the fuselage, right behind the pilot. When the pilot wants to land, doors open on the top and on the bottom of the aircraft. A drive shaft from the main engine spins this fan up to incredible speeds. The fan sucks in cold air from the top and blasts it down, creating about 20,000 pounds of lift. At the same time, the main engine's nozzle in the back swivels 90 degrees to point downward, providing another 18,000 pounds of heated thrust. It even has smaller nozzles coming out of the wings to provide roll stability. The whole thing is controlled by a fly-by-wire computer system that makes thousands of adjustments per second to keep the jet perfectly stable. For the pilot, the process is, honestly, surprisingly simple. They just use the controls to descend and position the jet, and the computer does all the hard work of managing the lift fan, the engine, and the control nozzles. It's a world away from the manual white-knuckle balancing act of flying a Harrier. This technology allows the F-35B to operate from the same small amphibious assault ships that used to carry Harriers, but now it brings a fifth-generation stealth fighter to the fight. It can go places where conventional carrier fighters like the F-A-18 just can't. This means a Marine Corps unit on a smaller ship has its own stealthy supersonic air cover. It can take off from a damaged runway or a remote forward operating base and conduct missions deep in enemy territory without being easily detected. It combines the flexibility of VTOL with the cutting-edge lethality of a modern stealth fighter, making it honestly one of the most formidable tools in any military's arsenal. So we've talked about how these planes work, but why go through all the trouble? Why spend billions of dollars developing these incredibly complex machines? The answer is simple. It's about access. In a perfect world, wars would be fought on open plains with long runways. But reality is messy. The fight is often in mountains, jungles, dense urban areas, high seas. In those places, a runway is a luxury you don't have. Think about a major conflict. The first thing an enemy targets is your airfields. A few bombs can crater a runway and stop conventional aircraft. Your multi-million-dollar jets are stuck on the ground. If you have F-35Bs or Harriers, that's not a showstopper. They can take off from a taxiway, a reinforced highway, or any small patch of concrete. That makes your air power more resilient and harder to shut down. You're not dependent on one big target. At sea, the same logic applies. A nuclear supercarrier is enormous. Only a few nations can build it. Many can build smaller amphibious assault ships. With VTOL jets, those ships become carriers. Navies can project air power in more places. Fleets can disperse, making them harder targets, with F-35Bs providing protection and strike capability. It's leveling the playing field. Having aircraft that can land almost anywhere doesn't just give you more options. It fundamentally changes how you think about military strategy. It's like being tied to a railroad network versus a fleet of all-terrain trucks. Suddenly the map looks different. Planners aren't constrained by established airfields. They can think more creatively and act more unpredictably. That unpredictability is a huge advantage. It leaves an adversary constantly guessing. For ground forces, especially expeditionary units like the Marines, this is revolutionary. The old model, secure a port or secure an airfield to bring in heavy equipment and air support that could take days or weeks and be heavily contested. With VTOL assets like the V-22 Osprey and the F-35B, forces can be inserted deep inland, supplied directly from ships offshore, and protected by air cover that needs no runway. That enables faster, more dispersed, and more surprising operations. It creates distributed lethality, smaller, agile units with real punch. This flexibility opens new tactics. Imagine a squadron of F-35Bs skipping the carrier and landing at a hidden temporary base to refuel and rearm. They launch another wave of attacks from an unexpected direction, then move again. Distributed STOVL operations make the force hard to track and target. The enemy can't just watch the carrier. The threat could be anywhere. Opponents must spread defenses thin against threats that didn't exist before VTOL. It also changes disaster relief. After a hurricane or earthquake, runways are often damaged or flooded. Getting aid is a race against time. A C-130 is useless with nowhere to land. A V-22 can take off from a ship or a distant undamaged airport, fly fast with tons of food, water, medical supplies, and land vertically in a village square or a stadium parking lot. That ability to bypass destroyed infrastructure has saved countless lives. It's a stark example of VTOL's military-born flexibility serving a greater good. Now, I've worked enough dirty jobs to know there's no such thing as a perfect tool. Every solution has problems. VTOL aircraft are no exception. For all their flexibility, they force serious compromises. The biggest is performance. All that extra machinery, the lift fans, rotating nozzles, gearboxes, extra ducting, is heavy. It's dead weight in cruise. Engineers call it the VTOL penalty. That weight hits a few things. First, range. Heavy lift systems mean less fuel, so they can't fly as far. Second, payload. Heavier airframes mean less room for bombs, missiles, external fuel tanks. A conventional F-35A from a runway can carry more than an F-35B taking off vertically. It's a trade-off, hitting power and endurance for anywhere landing. Then, complexity and cost. Not simple machines. Moving parts, sophisticated software, exotic heat-resistant materials, it adds cost and hours. VTOL programs like the V-22 Osprey and the F-35B are among the priciest in history. They need more maintenance hours per flight hour. The mechanics require highly specialized training. Keeping them flying is dirty, expensive, never-ending work. Finally, operational hazards. Blasting superheated jet exhaust at the ground is violent. It kicks up massive dust and debris which can be ingested and damage engines, a huge problem in sandy environments. The heat can melt asphalt or damage ship flight decks without special non-skid treatment. Not deal breakers, but real-world grimy problems to manage every operation. VTOL flexibility doesn't come for free. So, what's next for this incredible technology? Well, the work is far from over. The success of aircraft like the V-22 and F-35B has proven the concept is not just viable, but essential. Engineers are pushing to reduce the VTOL penalty. Lighter, more efficient, less complex. New propulsion is key. More powerful, fuel-efficient cores, plus exploring all-electric and hybrid electric lift. Quiet electric fans for vertical lift with a conventional jet for cruise could boost efficiency and cut noise, simplifying today's linkages. VTOL is also scaling down with unmanned aircraft that launch anywhere, watch for hours, and recover without runways, some even tail-sitters. The line between helicopters and planes is blurring. Faster, farther, more survivable while still landing anywhere. It's clear the dirty, difficult, brilliant job of defying gravity without a runway will be central to how we fly, fight, and provide aid for a long time to come.